19 introduces disaccharides. And for principles of chemistry, there are at least 3 disaccharides that you'd want to know. And those are, first, maltose, second, lactose, and third, sucrose. Sucrose is table sugar. Now, you know these are all sugars because they all end in OSE. That's the signature for a sugar. And there are a few things you want to know about each of these. First, you want to know what monosaccharides that these are made up of. So, which monosaccharides? Because these are all disaccharides, so they're going to be made up of 2 monosaccharides. The other thing you want to know is what type of a bond is holding the 2 monosaccharides together. That is called the glycosidic bond. The glycosidic bond. Glyco comes from the same word as glucose. It's for the Greek word meaning sweet. So that's just a bond holding together 2 sweet things. In other words, a bond holding together 2 sugars. That's a glycosidic bond. And then you want to identify, and that's it. Those 2 will help you know the name of these. Okay, for maltose. Maltose is, you'd want to know, is glucose and glucose. So if you connect 2 glucoses together, you get maltose. Maltose is in things like beer. That's why they describe beer as being malty. It depends on the amount of maltose in it. The glycosidic bond, this is like a $10 name for this. The glycosidic bond holding together maltose is an alpha 1,4 glycosidic bond. So that's alpha 1,4 glycosidic bond. Now that alpha is referring to, this alpha here is referring to the, whether the oxygen in the bond that holds the 2 sugars together is going up or down. So for example, if you were to look at this one down here that we'll do in a second, this bond right here, that ether, an oxygen bonded to carbons on each side, that ether is the glycosidic bond. And so you can see that the oxygen here is going up. Just like when an OH goes up, it's beta. It's the beta form of the ring, the beta isomer that we did in a previous problem. Now, when this ether is going up, it would be the beta form of a glycosidic bond. So the alpha form means you're going down. The oxygen would be going down. You could see an example of that maybe here. So you can see how this oxygen is going down on this ring, so it's a beta glycosidic bond. Okay, so in maltose you have, it's going down. When it's going down, it's alpha. Yeah, going down is alpha. If the O is going up, it's beta. So that's beta, this is alpha. So maltose is connected by an alpha glycosidic bond. How about the 1,4? You always start numbering rings at the carbon to the right of the oxygen in the ring. Whenever you look at a ring, orient yourself by the oxygen in it. Then go to the right of that. That's carbon number 1. And you can number the carbons in the ring going around like so. So that's, let's say, the first carbon. If you want to do the second one, orient yourself by the oxygen in the ring. Go to the right of it. That's carbon 1. Then you can go clockwise around the ring. So if you look back at the glycosidic bond here, you can see that it is connecting carbon 1 on the ring on the left to carbon 4 on the ring on the right. And so it's called a 1,4 glycosidic bond. I'm going to leave that numbering there. We're going to use that again in a second when we go through this problem. So I just wanted to give a general overview of what this stuff means. Glycosidic bond means you're connecting 2 sugar rings. Alpha means that the oxygen is going down. and between the two rings, and the 1,4 means that it's connecting carbon 1 on the one ring to carbon 4 on another, on the second. Okay, so that is maltose. How about lactose? Lactose has the two monosaccharides that make up lactose is glucose and galactose. And lactose is connected by a beta 1,4 glycosidic bond. So in the case of lactose, the two rings are going to be connected, carbon 1 on one ring to carbon 4 on the other, and the oxygen in the glycosidic bond will be going up relative to the ring on the left. And that will be lactose. Now sucrose is a little easier to identify. Sucrose is made up of two monosaccharides, glucose and fructose. Remember, fructose is the sweetest monosaccharide, and sucrose is table sugar. It's one of the sweeter sugars for the reason that it contains fructose. Fructose forms a 5-membered ring, as opposed to a 6-membered ring, and so it's easier to picture here. It's easier to pick out, as we'll see in a future problem. The type of glycosidic bond is alpha beta 1,2 glycosidic bond. We'll talk about that a little bit more when we see a sucrose, and when we see that in a problem, and it'll illustrate what all of that means. But for right now, you should know that these are the facts. You want to know 3 disaccharides, maltose, lactose, and sucrose, and you want to know 2 things about them: the monosaccharides that make them up, and the glycosidic bond that connects the 2 monosaccharides. Notice all of them have glucose. It's just the second one that differs for the 3 disaccharides. Glucose in the case of maltose, galactose in the case of lactose, and you can remember because of the lactose inside galactose, and then fructose in the case of sucrose. Okay, so let's apply those rules in identifying these things in problem 19. Problem 19 says for each of the following, give the monosaccharide units, so that's going to be one thing. Let me do this. Monosaccharides, that's the first thing that they want. Produced by hydrolysis, that just means if you were to break this apart, remember lysis means break apart. If you break that apart using water, hydro, what 2 monosaccharides would you get? That's the first thing. The second thing is the type of glycosidic bond. So the type of glycosidic bond. And then they want you to name the disaccharide. Name the disaccharide, that would be these top things here. Maltose, lactose, or sucrose. Now they say including alpha or beta. For our purposes, we won't have to worry about that. I'll discuss it, but it's not the main thing to take away from these problems. Okay, so first, I think the easiest way to identify the disaccharide you're dealing with is to look at the glycosidic bond. Now we saw already, now the glycosidic bond is the bond that connects the 2 rings. It's that ether there, the oxygen with carbons on both sides, that connects the 2 sugars. And there are 2 things you want to recognize about it. You want to recognize whether that oxygen is going up or down relative to the ring on the left. So you can see here that this oxygen is going up relative to that ring. And the rules are the same for identifying alpha or beta earlier. If it's going up, then it's beta. If it's going down, then it's alpha. So here it's going up, and so we know that it is a beta glycosidic bond. Next, look at what carbons it's connected to. Carbon number 1 and carbon number 4. So this is a 1,4 glycosidic bond. So altogether, we have a beta 1,4 glycosidic bond. Now, go back up to this table, which would be in your brilliant mind, and then see which of the disaccharides has a beta-1,4-glycosidic bond. And the only one is lactose. Sucrose has an alpha-beta-1,2 glycosidic bond, and maltose has an alpha-1,4 glycosidic bond. So this must be lactose. So first we know this is lactose. That answers one part of the question. But now that we know that it's lactose, we know what type of glycosidic bond it has. We already identified that, so that's another part of the question. It's a beta-1,4 glycosidic bond. Beta-1,4 glycosidic bond. That's this, a second thing they were asking. And last but not least, they wanted the monosaccharide units. Well, for lactose, the monosaccharide units are glucose and galactose. So glucose and galactose. So the three things they were asking for were the monosaccharide units, glucose and galactose, the type of glycosidic bond, beta-1,4 glycosidic bond, and which disaccharide it was, lactose. Okay, now they included this other thing at the end. It says including alpha or beta. So what are they referring to there? Well, remember, when you're identifying whether a ring is alpha or beta, you're orienting yourself by the oxygen in the ring, and you're looking to the carbon to the right of it. So that in this case, it would be this one right here. If the oxygen on that goes up, it's beta. If it goes down, it's alpha. Well, when we named the glycosidic bond, we used the ring on the left, this ring. But the ring on the right also has an oxygen in the ring you can orient yourself by, a carbon to the right of it, and an oxygen either going up or down. This ring on the right can also be either alpha or beta. Because the OH in that ring is going up, that ring is going to be beta. And so this would actually be beta lactose. You could imagine still having this beta-1,4 glycosidic bond, but just this OH on the right would be going down, switched with that hydrogen there. In that case, you would still have lactose. It still has the beta-1,4 glycosidic bond. It still has glucose and galactose, so it'd still be lactose, but it would be alpha lactose. So that's what they mean when they're saying including the alpha or beta there. Okay. Let's try that with another disaccharide. So we have three things we're looking for: monosaccharide units, glycosidic bond, and name of the disaccharide. I recommend you start with the glycosidic bond. Once you get that, everything sort of falls into place. The glycosidic bond is the ether, the oxygen connected to two carbons, that connects the two rings. Now, one thing you'd want to do is to number each ring. And so here, orient yourself by the oxygen in the ring. Go to the right of that, that's carbon number 1. Then go clockwise around the ring. 2, 3, 4, 5, 6. That's one ring. Next ring, orient yourself by the oxygen in the ring. Go to the right of that, that's carbon 1. Then go clockwise around the ring. 2, 3, 4, 5, 6. So already we can see that whatever this is, this glycosidic bond is connected by a 1,4 glycosidic bond. That's what the oxygen here in this glycosidic bond is connected to, the carbons on those two rings. Okay, next. To identify whether the glycosidic bond is alpha or beta, look at the ring on the left. Is the oxygen going up or down? Here it's going down. If it's going down, then it is alpha. So this is an alpha glycosidic bond. Specifically, it's an alpha-1,4 glycosidic bond. Okay. Now, alpha-1,4 glycosidic bond, that you would refer to your memory and see is, oops, let me just clear that is maltose. That's the only one that has an alpha 1,4 glycosidic bond. So we know that this must be maltose. Okay, so we figured out two things so far. One is the glycosidic bond, which was an alpha 1,4 glycosidic bond. Next was the disaccharide. The disaccharide was maltose. Put that in purple here. And last but not least, we need the two monosaccharides that are making this up. Now, if we know this is maltose, then that has to be glucose and glucose, making that up. So the two monosaccharide units are going to be glucose and glucose. So that is that. Now, they also include whether the disaccharide is alpha or beta, right here. And so remember, when we decided whether this glycosidic bond was alpha, we looked at the left ring and we saw that the O was going down. Well, the right ring also has the carbon next to the oxygen and an OH coming off of it. So that can either be alpha or beta. Because it's going down, that ring is alpha. And so this is really alpha maltose. If this OH were going up, then it would be beta maltose. You know it's still maltose because you still have the alpha 1,4 glycosidic bond, and it's made up of the same two monosaccharides. It's just the position of that OH on the right ring. So this would technically be alpha.